Okay, inequalities and graphs, page 76 onwards, and that's section 7.6. Now, what I've got there is pasted up question 1 on exercise 7.6, and the questions are actually on page 78. It's quite hard to show the inequality y is less than 0, y is greater than minus 4. I'm going to start with C, and then you'll see what I'm getting at, so to speak. Right, let's just do a rough grid. If this is a very simple pair of axes, it's very tiny, just a little picture, there's the y, there's the x. If I want to show the inequality x is less than or equal to 2, I must first draw in the line, and it's only a rough sketch, x equals 2. Right, that's the line x equals 2, and right there will be the coordinate 2, 0. In order to show the region where x is less than or equal to 2, I need to shade out to the left of that line. So all this region here is where all the x values of all the coordinates that ever existed have an x value less than 2. Alright, so to the left of this black line, x is less than or equal to 2. Please note that if I'm equal to 2, I'm allowed to sit on that line as well. So I can be less than 2 or equal to it. Okay? Now I think on the right side here I'll get one more in there. I've got the same question shown on the other page, so I'll get back to that in a minute. Now I want to do this one here. Y is greater than minus 1. Well, if that's the y-axis, that's the x-axis. The y lines, you will recall, go horizontally, so it will be roughly there then. Y equals minus 1, and the inequality says I've got to go greater than or equal to minus 1. In other words, greater than are all the coordinates above this line where the y value is greater than minus 1 or equal to it. Again, to be equal to it, I'm allowed to sit on this line. I'm allowed to be, for example, 1 minus 1 or 2 minus 1, as long as I'm in this region, on the line or above it. Which comes to the next little bit, which is quite hard to draw, so I'll do it in yellow. I'll go back to this y is less than 0 business. Now, I need to draw a pair of dotted axes because the line y equals 0 is actually the x-axis. So I'm going to have to draw this one dotted, freehand. So that's the line y equals 0. In other words, the x-axis. I'm going to just draw the y-axis in normally, like so. So that's the y-axis, and that's the x-axis, known as the line y equals 0. Remember, all the y lines go horizontally, and it says I've got to be less than 0, but not equal to it. So what I'm going to do is shade out the region below the dotted line, which represents the fence y equals 0. But I've got to be below it, therefore I shade all the region below the line y equals 0. I'm not allowed to be equal to 0, it's got to be less than 0. So therefore we represent the less than with a dotted line, because I'm not allowed to be actually on the line, in which case it will be less than or equal to, as in part C here and part D there. Alright, so I'm not allowed to be that. Incidentally, that was question A, which makes this question a little bit more meaningful. I'm going to try and squeeze it down here and do a yellow grid. So just a pair of axes, y-axis, x-axis, again very rough. So I've done that one. I'm now going to do x is greater than minus 4. Well, these are all the positive x values and negative x values are down here. So if I say the line x equals minus 4 is about there somewhere, then to be greater than it, I've got to be to the right of that. And of course, I've forgotten to show that this is supposed to be a dotted line, just rub out a little bit of it. So because I'm not allowed to be equal to minus 4, but I can be above it. And therefore I'm going to shade out everything to the right of this, because to the right of that line, all the x values are greater than minus 4. Alright, so just keep shading. Again, that's an independent question from that one right there, but just trying to keep it all on one screen. On the other page, I've got the same questions. I'll just do that question on the other side and then move on. Okay, I was going to do x plus y is greater than 4. Well, I can fit it here quite nicely. Do like a little pretend grid. Now, if x plus y is greater than 4, first of all I've got to plot the line x plus y equals 4. Well, if that is the point 4, 0, say, and that is the point just there, 0, 4, if you do the maths on that, you can see that 0 plus 4 makes 4, and 4 plus 0 also makes 4. So if I have to join these 2 points, and I'll actually use this straight line function there. I now have the line x plus y equals 4. Now it says I've got to be above that line, and therefore that should have little cuts in it like this. It should be like dotted out, really, shouldn't it? I'm not allowed to have a solid red line. It's got to have dashes all the way through it, but I didn't do that, so I'm sorry. Anyway, x plus y has got to be above 4. In other words, what I require is the entire region above this line, because anything below this line, the x and the y values added together will come to less than 4, and I want to be above 4. Let's just test it out. If this is with the point, say 1, 1, right there, we have 1 plus 1 makes 2, and x plus y is now 2, and 2 is less than 4. Therefore, I've definitely got the side which is less than over here, and here will be the side that is greater than. Alright? Just shade the right side to be fine. Now, this next lot is a representation of question 2, and it's an awful lot easier to define the regions because the pictures have been drawn for us, so this is going to be easy now. Now look, that's the line x equals 2. Like I said, we have dotted lines to represent a region which is less than or greater than, but not equal to. Now I've got to describe the shaded region. Well, here I'm to the left of the line x equals 2. Therefore, this region is going to be x is less than 2. Alright? That's the region x less than 2, and the white region would be x is greater than 2. Please note, I'm not going to allow them to be equal to it because I've got a dotted line. Part B. That's the y line, y equals 4, and it's dotted. Therefore, above that dotted line, we have the region y is greater than 4, and here will be y is less than 4. Not that it asks me that, but they could have asked that. Question C. I've got a solid line, y equals minus 3, so therefore to be below that line, I am y is less than or equal to minus 3. Is that alright? Solid line. I'm actually allowed to sit on that line. There you go. 3 minus 3, 4 minus 3, minus 2 minus 3. I can be there and still be within the defined region because my y is allowed to be less than or equal to minus 3. Now over here, part D, again solid line, I'm allowed to equal to 1. So everything above this line to the right is defined as the region x is greater than or equal to 1. Alright, I'm allowed to be on that line there. 1, 1, 1, 2, 1, 3, 1 minus 2, 1 minus 3. All the x's are 1s. I'm allowed to be there, and I can still be part of this region. Let's do a quick test point. The coordinate there is 4 minus 1. Please note the 4 is the x value, and 4 is greater than minus 1. So I know I've named the region correctly. The lines don't always have to be vertical and horizontal. They could be like this, the famous line y equals x. Now this region here, I'm in a region where y is less than x. Please note dotted. I'm not allowed to be equal to it. Let's just test it out. What have I got here? I've got the coordinates 3, 1. Is my y value less than my x value? Yes, it is. Therefore, I've named the region correctly because the x value for 3 is bigger than the y value, which is 1. Alright? Similarly, I have the line x plus y or y plus x equals 3 in the similar way that I had the line x plus y equals 4 in this other question here. Going back. So because I want to go below the line, I have the region y plus x is less than 3. Let's just test it out. Let's just test the point there. 1, 1. 1 plus 1 is 2, and 2 is less than 3. Therefore, I definitely named the region correctly.